this video, we are going to solve problems under set. So we have this problem. It says that P is such that X is greater than or equal to 0, but less than or equal to 12. Then Q is X is such that X is less than minus 3. Sorry, X is greater than minus 3, but less than 10. And the subsets of the universal set, mu equals X is such that X is greater or equal to minus 3, but less than or equal to 12. If P prime intersection Q prime is equal to X, then we should find S. So the first thing is that we need to list the set of the universal set. So U is said that X is from minus 3 to 12. So we have minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12 itself. So let's list the members of P. The question says that P is saying that X is greater or equal to 0, but less than or equal to 12. So P is 0 to 12. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it ends at 12. Then Q. X is saying that X is greater than minus 3 but less than 10. So since it's greater than minus 3, then it means you have to start from minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. But it is less than 10, so we need to end at 9. So we are supposed to find PS. However, let's find P prime. So what is P prime? P prime is all the elements in the universal set that are not in set P. But we know that set P starts from 0 to 12. So the P prime is from minus 3, minus 2, and then minus 1. Now let's find Q prime. Q prime is all the elements that are in Q but are not in the all the elements that are in the universal set but they are not in Q. Now Q starts from minus 2 to 9. So that means that minus 3 is one of them. Then minus 2, minus 1, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10, 11, and then 12. So now we are in a good position to find S. We know that S is equal to P prime intersection Q prime. And this is equal to elements that are in P prime and Q prime. So we see that it is minus 3. So minus 3 is the only element that is in P prime and in Q prime. And therefore, it is X is said that X is equal to minus 3. So the answer is answer A. In a class of 25 students, 6 study social studies, so it is represented as A. 14 study science, it is represented as B. And 3 study both social studies and science. So we are supposed to find the number that study A complement intersection B complement. So let's sketch the Venn diagram to represent this information. The social studies is represented as A. Then the science is represented as B. Now, 3 study both social studies and science. So that means that this place is 3. And it says that 6 study social studies. So that means here ought to be 3 because 3 plus 3 is 6. And then 14 studies science. So 14 minus 3 is 11. So now, the question is saying that we should find A prime intersection B prime. So what is that? Let's use a little Venn diagram here to determine that. So here's A and then here's B. So let's find A prime. A prime is all the elements that are outside A. So all of this region. This is A prime. A itself must not be included. Now let's find B prime. So this is A and then this is B. So B prime is also all the elements that are outside set B. So B itself must not be included. So you can see that A prime intersection B prime is the outside region. So this is the region that we are looking for, because that is the region that is common to both A prime and B prime. So let's represent that region by capital D. So what it means is that if we sum everything here, we should get 25. So capital D plus, now the question said that 14 steady science. So that means that here's 14 and then 6 steady social studies. So if we add it to, if we cover this, it will be left with 3. So plus 14 plus 3. And then that is equal to 25. So this implies that D is equal to 25 minus 14 plus 3 is 17. And therefore D is equal to 25 minus 17 is equal to 8. Let mu equals, into bracket, a set of 1, 2, 3 up to 20 be the universal set. P is equal to factors of 18 and Q is equal to factors of 12. So we are supposed to find number of P union Q prime. So let's list the members of P. So P is equal to factors of 18. We have 1, we have 2, 3, 6, 9, and then 18 itself. And then Q is factors of 12. So the factors of 12, we have 1, 2, 3, 4, 6, and then 12. So let's find P union Q. That is going to give us 1, 2, 3, there's a 4 here, but there's no 5, so we have 6, then from 6 we go to 9, 12, and then 18. So that is P union Q. So we can find P union Q all prime. So these are the elements that are in the universal set, but they are not in P union Q. So now the universal set is 1 to 20. So 1, 2, 3, 4. So 5 is one of them. And then 6. We have 6 here. So 7. It's not there. Then 8. 9 is there. So 9. And then 10. 11. 12 is there. 13. 14. 15, 16, 17, 18 is there, 19, and then 20. So if we are supposed to count the number, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of elements that form P union Q prime is equal to 12. A group of 34 women sells at least one of the following foodstuffs: yam, maize, and then plantain. Of these, 22 sell yam and plantain, and no one sells all 3 items. Draw a Venn diagram to illustrate this. The second part says find the number who sells maize and plantain only. Then the third part, what is the probability that a woman selected at random from the group sells plantain only? So let's draw the Venn diagram first. This is our Venn diagram. It is a diagram of 34 women. Then he says that it is they sell yam, maize, and then plantain. And he says that of these, 22 sell yam. So the number of yam is 22. But I'm sorry, I made a mistake in writing the question. So the question says that 14 sells maize, 18 sells plantain, 7 sells yam and maize, 9 sells yam and plantain, and no one sells all 3 items. So please, this is a mistake that I inserted. into it. So he says no one sells all three items, so this place is 0. Then he says that 22 sell yam, and then 14 sell maize, so the maize part is 14, and then 18 sells plantain, so here's 18. Then he says that 7 sells both yam and maize, so here's yam and then maize, it is 7. And then he also says that 9 sells yam and plantain, so here's yam and plantain, here is supposed to be 9. Let's represent here by capital A, capital B, capital C, and then capital D. A is equal to 22 minus into bracket 7 plus 9. And if you do this, we are going to get 6. So it means that here is A is equal to 6. So now, having gotten A equals 6, we can find B. You see that when we close here, we are left with 6, 7, and B. So if we sum everything here, it should give us 34. So this region is 18. So 18 and then plus, if we cover it, we are left with 6, 7, and B. So 18 plus 6 plus 7 plus B is equal to 34. So B is equal to 34, then minus, now 18 plus 6, 24, then 24 plus 7 is 31, so here is 31, and therefore B is equal to 3. So here is B equals 3. So having found B, we can now find C, because we know that C is equal to all the region that belong to maize is 14, so 14 minus into bracket 7 plus 3, and that is equal to 40 minus 10, and that's equal to 4. So therefore C is equal to 4. Now, having found C, we can find D. So because we know that all of this region is what? 18. So D is equal to 18 minus into bracket 9 plus C, which is 4. So 9 plus 4 is 13. 18 minus 13 is equal to 5. So here is 5. Now we can answer the questions. So we've drawn a diagram to illustrate that. Find the number who sells maize and plantain only. So here's maize and then plantain. Maize and plantain only, so it is 4. So maize and plantain only is what? 4. That is C. And this is what we did for C. Then he also says that what is the probability that a woman selected at random from the group sells plantain only? Now, plantain only is 5. So since we are talking about probability, then the probability is plantain only, which is 5, divided by the total universal set, which is 34. So it is 5 over 34. The breakfast menu in a hotel is a choice of yam, plantain, or both. The Venn diagram shows choices made by 48 guests in the hotel. A. Find the value of Y. And then B. What is the probability that a guest selected at random chooses either yam or plantain, but not both? So the question says there are 48 guests. So the universal set is equal to 48. So that means that if we sum all of this, we are supposed to get 48. So let's sum. So we have 2y minus 1, then plus y, then plus into bracket y minus 3 squared is equal to 48. So now 2y plus y will give us 3y. So here will be 3y minus 1, then plus, if we expand this, here is y squared, then minus 6y, then plus 9 is equal to 48. So let's bring the 48 here. So we have y squared, then here is minus 6y, here is plus 3y. So it becomes plus 3y minus 6y becomes minus 3y. Then if we bring 48 here, now minus 1 plus 9 is 8. 8 minus 48 will give us minus 40 equals 0. Now, two numbers are, if we multiply, we'll get minus 40. But if we add, we'll get minus 3. So you see that 8 times minus 8 times 5 is minus 40. However, minus 8 plus 5 is minus 3. So we have y minus 8 then times y plus 5 equals 0. So the values of y is equal to 8 or y is equal to minus 5. However, we cannot have negative people, and therefore y cannot be minus 5. So y is equal to 8. Now, so we found the value of y. Then the next thing is, what is the probability that it gets selected at random, chooses either yam or plantain, but not both? So the B part, yam or plantain, but not both, is 2y minus 1, then plus y minus 3 all squared. But we know that y is 8, so 2 times 8 minus 1. Sorry, minus 1, then plus into bracket 8 minus 3 all squared. So 2 times 8 is 16. 16 minus 1 is 15 plus 8 minus 3 is 5. 5 squared is 25. Now, 15 plus 25 is equal to 40. So the probability is equal to the 40 divided by the total, which is 48. So 8 will divide 40, 5. And then 8 will divide 48, 6. So the answer is 5/6. If P, Q, and R are set such that number of P is equal to 20, number of Q equals 16, and the number of R is 21, and number of P intersection Q is 7, and number of P intersection R is 8, and number of Q intersection R is 5, and the number of P intersection Q intersection R is 3. We should represent this on a number line. And then the B passage, we should find number of P union Q union R. And then the probability of P union Q prime intersection R. So let's first represent this on a Venn diagram. This is our Venn diagram. So we are talking about P, Q, and then R. So the number of P is 20. The number of Q is 16. Then the number of R is 21. Now, all three, P, Q, and R is 3. And he says that number of P intersection Q is 7. So P intersection Q is 7. Since it's 7, 7 minus 3 is 4. So here ought to be 4. P intersection R is 8. So P intersection R, 8. 8 minus 3 is 5. And then we have Q intersection R is 5. So Q intersection R here is 5. 5 minus 3 is 2. So now, we can represent the rest by capital A, capital B, then capital C. So we've represented it on a Venn diagram. So now he says we should find number of P union Q union R. So that means we are supposed to find the universal set. However, we can only find the universal set if we know the values of A and then B. So let's first find A. So from A, we know that all of this region is 20. So A is equal to 20 minus 4 plus 3 plus 5. So that is equal to 20. 4 plus 3 is 7. 7 plus 5 is 12. 20 minus 12 is 8. So A is equal to 8. Now, having found A, we can also find B. B is equal to 16 minus 4 plus 3 plus 2. So 4 plus 3 is 7. And then 7 plus 2 is 9. 16 minus 9 is equal to 7. So B is equal to 7. So here is 7. Now, having found this, we can find P union Q union R. Please, if you don't understand this, I have already done an earlier video on this, so you can watch that video. So P union Q union R is the universal set, all the elements here. So all of this region is 21. Then plus, if we cover this, what is left is 8, 4, and then 7. So plus 8, plus 4, and then plus 7. So this is equal to, now, 21 plus 8 is 29. 29 plus 4 is 33. 33 plus 7 is 40. So the universal set is equal to 40. U is equal to 40. And then now, it says we should find the probability of P union Q intersection R. So P union Q. So that is all the elements in P. Okay, so let's first draw a little Venn diagram and illustrate that. So we are talking about P, Q, and then R. So P union Q is all of this region. But then the question is in P union Q prime. So intersection R. Now P, Q, and then R. So P union Q prime is all of the region outside P union Q. So it is this region. So P union Q intersection R, you see, is going to be the value of what? C. So we are supposed to find C. So what is C? C is equal to, now all of that region is 21. So 21 minus into bracket 5 plus 3 plus 2. Now 3 plus 2 is 10. 3 plus 2 is 5. 5 plus 5 is 10. 21 minus 5 is 11. So C is equal to 11. But since it's talking about a probability, it means that we must take the 11 and divide by the total. So the probability is equal to 11 divided by the universal set, which is what? 40. So that is the probability. In the diagram, P, Q, and R are subsets of the universal set mu. If the number of the universal set is 125, find the value of X, then II. Number of P union Q intersection R prime. So to find the value of X, all we need to do is to sum everything in the Venn diagram and equate it to the universal set 125. So we are going to get 16 minus 2x, then plus 5x, plus 4x, plus 8x, then plus 6 plus x, plus 7x, plus 19 minus 3x, then plus 4 is equal to 125. So if we add all the x's and we add all the numbers, 16 plus 6 plus 19 plus 4, all of that is equal to 45. Then minus 2x plus 5x will give us 3x, plus 4x plus 8x plus x plus 7x minus 3x. That will also give us 20x. And this is equal to 125. So 20x is equal to 125 minus 45. So 20x is equal to 80. This implies that x is equal to 4. So we've gotten x as equal to 4. So the question is saying we should find number of P union Q intersection R prime. Let's illustrate that on a little Venn diagram here. So this is P, this is Q, and then this is R. So P, Q, and then R. Let's first find P union Q. So P union Q is this region. Now let's draw another one and find R prime. So this is P, Q, and then R. So what is R prime? All the region that is outside of R. So this is R prime. So what is the commonality between this region and this region? You can see that we are talking about these values, this value, and then this value. And therefore, number of P union Q intersection R prime is equal to 16 minus 2x, then plus 5x, and plus 6 plus x. So this is equal to 16 plus 6 is 22. So here is going to give us 22, and then minus 2x plus 5x is plus 3x, and plus x will give us plus 4x. But we know that x is equal to 4, so this becomes 22 plus 4 times 4, and that is going to give us 38. So number of P union Q intersection R prime is 38. In a class of 50 students, 24 like football, 21 like basketball, and 18 like cricket. 6 like football and basketball only. 3 like basketball only, and then 5 like all 3 games. And 14 did not like any of the 3 games. So the first part is we should illustrate this on a Venn diagram. The second part is we should find the number of students who like football and cricket only, then exactly one of the games. So the universal set U is equal to 50 because we are talking about 50 students. Then 24 like football, so football is 24. Then 21 like basketball, so basketball is 21. Then 18 like cricket, so here's cricket, it's 18. Now it says 5 like all 3 games, so this one is 5. Then 14 did not like any of the 3 games, so the 14 comes outside here. And he says that 6 like football and basketball only, so football and then basketball only is 6. Please, this is different from 6 like football and basketball. If it was that way, then we would have subtracted the 6 from 5 from the 6. But he says football and basketball only, so that is how come we didn't do any subtraction. And he says that 3 like basketball only, so this is basketball only, so it's 3. And then the question says that 5 like all 3 games. We have already shown that. Now you see that we can easily find A if we close this box. See that we are left with A, 6, 3, and then 14. If we sum all, we are supposed to get 50. So, but we know that the cricket is what? 18. So 18 plus, let me close it again. You see A, 6, 3. So plus A plus 6 plus 3, and then plus those who are not doing anything, which is 14. That is equal to 50. So 6 plus 3 is 9. 9 plus 14 is 23. 23 plus 18 is 31. So A is equal to 50 minus 41. Sorry, it was 41. So A is equal to 9. So here's A equals 9. So since we found the value of A, we can find B because all of that region is 24. So B is equal to 24 minus into bracket 9 plus 6 plus 5. So B is equal to 21 minus 9 plus 6. 9 plus 6 is 15. 15 plus 5 is 20. Therefore, B is equal to 1. Sorry, I made a mistake. The football is 24, but I wrote 21. So here's 24. 24 minus 20 is going to give us 4. So B is equal to 4. So here's 4. So now we can find D because all of this region is 21. So D is equal to 21 minus 5 plus 6 plus 3. Now, 5 plus 6 is 11. 11 plus 3 is 14. So D is equal to 21 minus 14 is 7. So here is 7. And having found D, we can find C because everything is 18. So C is equal to 18 minus into bracket 4 plus 5 plus 7. Now 4 plus 5 is 9. 9 plus 7 is 16. Therefore 18 minus 16 is 2. So C is equal to 2. Now the question says we should find football and cricket only. So football and cricket only. That is what we did. It is this B. Remember B is 4. So here's equal to 4. then exactly one of the games. So exactly one of the games is this 9 plus 3 and then plus C. So exactly one of the games is equal to A plus 3 plus C. But A is 9 plus 3 and then C is 2. So 9 plus 3 is 12. 12 plus 2 is 14. So this is equal to 14.